Introduction. In a vapor compression refrigeration system, the refrigerant is the core working fluid responsible for transferring heat from a low-temperature space to a higher-temperature environment. Throughout the cycle, the refrigerant continuously changes phase between liquid and vapor. However, this process does not occur independently. It relies on several precisely engineered components working together to maintain system stability and efficiency. One of the most important yet often overlooked components in HVAC systems is the receiver. Although it may appear to be a simple storage vessel, its function is critical for proper refrigerant management, compressor protection, and system stability. What is a receiver in HVAC? A receiver is a pressurized vessel installed downstream of the condenser on the liquid line. Its primary purpose is to store excess liquid refrigerant and ensure a steady supply of liquid refrigerant to the expansion valve. In HVAC systems, cooling demand constantly changes. During peak load conditions, most of the refrigerant circulates through the system. However, when the cooling load decreases, not all refrigerant is required in active circulation. This excess liquid refrigerant must be stored safely to prevent operational issues. The receiver provides this storage capacity. By acting as a surge accumulator, the receiver stabilizes refrigerant flow and pressure variations within the system. Why is a receiver important? When cooling demand decreases, excess liquid refrigerant can accumulate in the condenser coil. This reduces the condenser's heat transfer efficiency and disrupts system performance. The receiver prevents this issue by collecting surplus liquid refrigerant. It acts as a reservoir, storing unused refrigerant during low load conditions and releasing it back into circulation when cooling demand increases. This ensures stable refrigerant flow, improved condenser efficiency, smooth system operation, reliable expansion valve performance, pump-down operation, and compressor protection. One of the most critical functions of the receiver occurs during system shutdown through a process known as pump-down. Before the compressor stops, a solenoid valve in the liquid line closes. The compressor continues running and pumps refrigerant from the evaporator into the receiver. This lowers the pressure in the evaporator and ensures any remaining liquid refrigerant vaporizes. If pump-down were not performed, liquid refrigerant could remain in the evaporator. Upon restart, this liquid could enter the compressor, causing liquid slugging. Since compressors are designed to compress vapor, not liquid, this can lead to severe mechanical damage. The receiver acts as a safe storage vessel during pump-down, preventing liquid accumulation in the evaporator and protecting the compressor. Maintaining liquid stability in the system. HVAC systems operate under varying load conditions, which cause fluctuations in condenser pressure and temperature. These fluctuations can lead to inconsistent liquid refrigerant supply to the expansion valve. If insufficient liquid reaches the expansion valve, the evaporator becomes starved, reducing cooling performance. On the other hand, excessive liquid can flood the evaporator and reduce heat transfer efficiency. The receiver maintains a stable pressure environment. This ensures a consistent and reliable supply of liquid refrigerant to the expansion valve, optimizing evaporator performance and improving overall energy efficiency. Receiver design and construction. Receivers are typically constructed from strong materials, such as steel or copper, to withstand high pressures and temperatures. The main components of a receiver include shell. The shell forms the main body of the receiver. It is designed to handle pressurized liquid refrigerant safely. The size of the shell is selected according to system requirements and typically allows storage up to about 80% of its total capacity to maintain safety margins. Dip tube. The dip tube extends from the outlet connection down into the lower portion of the receiver, where liquid refrigerant collects. It ensures that only liquid refrigerant, not vapor, leaves the receiver. The dip tube is designed to draw refrigerant from the cooler bottom region of the tank. In many designs, a filter mesh is installed at the submerged end to prevent debris from entering the system and damaging the expansion valve. Applications of receivers. Receivers are commonly found in both split systems and chillers. In split systems, the receiver stores excess refrigerant during low cooling demand and ensures steady liquid supply to the expansion valve. In chillers used in commercial and industrial buildings, receivers play a crucial role in stabilizing pressure fluctuations and maintaining consistent refrigerant flow to evaporator coils. They are particularly important in systems where load variation is frequent. Difference between receiver and accumulator. It is important to understand the difference between a receiver and an accumulator. Receivers are located downstream of the condenser on the high-pressure liquid line. Their function is to store excess liquid refrigerant and ensure consistent supply to the expansion valve. Accumulators, on the other hand, are located on the low-pressure suction line before the compressor. Their purpose is to prevent liquid refrigerant from entering the compressor. They act as a protective device by separating liquid from vapor before it reaches the compressor. In simple terms, receiver stores liquid refrigerant for system control. Accumulator protects the compressor from liquid slugging. Maintenance of the receiver. Like all HVAC components, receivers require regular maintenance to function properly. Common issues include leaks, which can reduce refrigerant charge and affect system performance. Debris buildup inside the receiver, which may clog the dip tube filter and restrict refrigerant flow. Incorrect refrigerant charge. Too little refrigerant prevents the receiver from functioning as a proper reservoir. Too much refrigerant can cause overflow and pressure instability. Symptoms of receiver problems. Several signs may indicate receiver malfunction. Reduced cooling capacity due to unstable refrigerant supply. Unusual noises such as hissing, bubbling, or gurgling near the receiver. Erratic pressure readings that differ from normal operating values. If any of these symptoms appear, inspection by a qualified technician is recommended. Conclusion: the receiver is a critical component in HVAC and refrigeration systems. Although it appears to be a simple storage vessel, it plays a vital role in refrigerant management, pressure stabilization, and compressor protection. By storing excess refrigerant during low-load conditions, facilitating pump-down operation, and maintaining stable liquid supply, the receiver ensures efficient and reliable system performance. Understanding the function and importance of the receiver is essential for every HVAC technician, engineer, and student.